FOIL, Part 1, The Basics. How do you do it? By Jeff Simpson. FOIL has a how and a why. How do you do it, and why do you do it that way? This Part 1 video deals with the question, how do you do it? If you prefer to understand why you're doing something and like to make sense of what it means before you learn how to do it, then watch the Part 2 video first. That's FOIL Part 2, Why Does It Work? FOIL is a step-by-step process used in algebra for multiplying and adding numbers that are arranged like this. Example, x plus 3 times x plus 2. The letters FOIL stand for first, outer, inner, and last. We'll deal with what that means in a little bit. Math teachers use the word foil, as in aluminum foil, to help students remember the letters FOIL in order. Some students find FOIL to be very confusing, and this video will help them make sense of it. When we add two numbers, example 10 plus 2, well, there's a first number, and there's a last number. First, as in F from FOIL, and last, L. Here is a picture of 10 plus 2. Let's say you've got 10 boxes plus 2 more boxes. When we add two variables, or in other words letters, say x plus y, there's a first letter and a last letter. Again, first is F, last L. We cannot make a picture of x plus y. Why not? Because letters can stand for a variety of numbers. The amount a letter stands for varies, and that's why letters are called variables. In this situation, we don't know what numbers the variables stand for, so we can't make a picture. When we add a variable and a number, for example, x plus 2, it doesn't seem quite right to say that there's a first letter, well, because it's the only letter, and a last number because it's the only number. Instead of that, we use the word term, which is an amount represented by either a letter or a number. So x is a term, and 2 is a term. We just call them terms. So when we add two terms, such as x plus 2, there is a first term, and there is a last term. This expression on the left has a first term and a last term, and this also has a first term and a last term. The positive or negative sign is actually part of the term. For example, we have x minus 2. The first term is positive. It's positive x. Usually we don't write a positive sign, we just assume that it's positive. The last term is negative. Notice it's not just 2, it's minus 2. Here's another example, negative x plus 2. The first term, negative x, is negative. And the last term, the sign goes with the number, is positive 2. So the last term is positive. Another example, negative x minus 2. The first term is negative, minus x. The last term is also negative, minus 2. When these two expressions are multiplied times each other, we begin by multiplying the first term times the other first term. And that will be x times x, which is x squared. When both first terms are x, as in this example, the first term multiplied times the other first term always gives us x squared. X times x, x squared. Here's another example showing the same thing. We keep getting x squared when we multiply the first times the first. Let's make a picture of this. Let's say if x is 2, then a picture of x squared looks like this, 2 by 2. 2 times 2 is 4, or 2 squared is 4. Another example. What if x is 3? Then a picture of x squared would look like this, 3 by 3, which is 9. 3 squared is 9. What if x is 4? Well, then a picture of x squared would look like this, and a picture of x squared if x is 5 would look like that. A picture of 2 squared actually makes a square shape. A picture of 3 squared also makes a square. That's why we call it 3 squared. And a picture of 4 squared makes a square. 5 squared also pictures a square. A square always has 4 sides. Quad means 4, and it comes from Latin. Quad is like our word quarter, 1/4 of a dollar. There's our number 4. Quad is also like the word quart, 1/4 of a gallon. Quadratic means made square because a square has 4 sides. This is also from Latin. Quadratic means made square. Here's an example of a normal equation. 5 plus 1 is 6. But this equation has a squared number in it, namely 5 squared. So it's called a quadratic equation. And quadratic equation just means there's something square in it. 5 squared is in the equation, so it's a quadratic equation. Here's another normal equation. X plus 1 is 6. And this equation has a squared term in it, x squared, so it's called a quadratic equation. In other words, an equation with something squared in it. When both first terms are multiplied, the resulting x squared is the first part of a quadratic equation. We multiply x times x, we'll get x squared. And there are other things will follow, but that's the first part of a quadratic equation. This example shows the same thing. There it is again. We keep getting x squared. After multiplying the first terms, later we will multiply the last term times the other last term. And that will be positive 2 times positive 3, which is plus 6. Last times last. But before we multiply the last terms times each other, there is something else we have to do. We must multiply the outer terms, those are the ones toward the outsides, and O stands for outer from the word foil. And then we'll multiply the inner terms. That's them toward the inside. And the letter I stands for inner. But which ones are the outer terms? This is what confuses some students. Well, let's imagine 4 people getting into the back seat of a car. We'll turn these terms into circles representing people. Here comes a car. The people are going to get into the car, or they can be passengers. There, they're all in. Which ones are toward the outside of the car? Those two are. They're toward the outside. And so those passengers are the outers. Outer. That's the O from foil. Outer. Which ones are toward the inside of the car? There they are, the ones in the middle. Those passengers are the inners. That's the I from foil. Inner. These passengers are the outers, and these terms are the outers. When we multiply the outers, x times 3, that's the same as 3x. These passengers are the inners, and these terms are the inners. When we multiply the inners, that's plus 2 times plus x, same as 2x. Looking at two terms, such as x plus 2, it's easy to tell which term is first and which is last. When there are only two terms, actually there is no inner or outer. There's just first and last. But when there are four terms, then you can find the inner and the outer terms. Here's how to do the FOIL method step by step. Our example is x plus 2 times x plus 3. We'll begin by multiplying the first term times the first term. X times x is x squared. Then multiply outer times outer, plus 3x. Inner times inner, plus 2x, and last times last, plus 6. Here's another look at the FOIL method. First times first, x squared. Outer times outer, plus 3x. Inner times inner, plus 2x. Last times last, plus 6. Combine like terms, 3x plus 2x is plus 5x. Bring down the other terms, so we have the whole thing. X plus 2 times x plus 3 equals x squared plus 5x plus 6. Here's another example, but using different numbers. The setup is the same. We'll do first times first, x squared. Outer times outer, plus 4x. Inner times inner, plus 5x. Last times last, plus 20. Combine like terms, plus 9x. Bring down the other terms, and there we have it. X plus 5 times x plus 4 is x squared plus 9x plus 20. When you multiply the last terms times each other, pay attention to the positive or negative signs. Here you see both signs are positive. Last times last, and the number term actually includes the sign before it. So it's not just 2, it's plus 2, or positive 2, times positive 3. Positive times positive gives us plus 6. But what if both signs are negative? Then what do you do? Last times last, and remember the sign goes with the number that follows it. So it's not just 2, it's negative 2 times negative 3. A negative times a negative gives us positive 6, or plus 6. What if the first sign is positive, but the second sign is negative? Well then, our last times last, we'll have positive 2 times negative 3. Positive times a negative gives us minus 6. And what if the first sign is negative, but the second sign is positive? Well, now we have minus 2 times plus 3. Negative times positive gives us minus 6, or negative 6. When you multiply the outer terms times each other, you must also pay attention to the signs. Here we'd have positive x times positive 3, which gives us plus 3x. What if both terms are negative when we're doing outer times outer? Well, we have negative x times negative 3. We multiply a negative times a negative. That gives us plus 3x. What if one of the terms is negative? Outer times outer, positive x times negative 3, positive times negative, minus 3x. And what if the other term is negative? Outer times outer, negative x times positive 3. Negative times positive, minus 3x. You must also pay attention to the positive and negative signs when multiplying the inners and the firsts. The sign always goes with the number after it. Here are 4 examples of first times first. X times x, x squared. Negative x times negative x, positive x squared. X times negative x, minus x squared. Negative x times x, minus x squared. Here are 4 examples of inner times inner. Positive 2 times positive x plus 2x. Another example, inner times inner, negative 2 times negative x, positive, plus 2x. Inner times inner, negative 2 times positive x, negative times positive gives us minus 2x. 4th example, plus 2 times minus x, negative 2x. Now let's look at 4 situations with different combinations of positive and negative signs. Our first situation, both signs are positive. First times first, x squared. Outer times outer, plus 3x. Inner times inner, plus 2x. Last times last, plus 6. Gather like terms, plus 5x. Bring down the other terms. X plus 2 times x plus 3 equals x squared plus 5x plus 6. Second situation, both signs now are negative. First times first, x squared. Outer times outer, minus 3x. Inner times inner, minus 2x. Last times last, plus 6. Gather like terms, minus 5x. Bring down the other terms, and we have x minus 2 times x minus 3 equals x squared minus 5x plus 6. Third situation, one sign is positive, the other sign is negative. First times first, x squared. Outer times outer, minus 3x. Inner times inner, plus 2x. Last times last, minus 6. Gather like terms, negative 3x plus 2x will give us negative 1x. but that is actually just the same as minus x. So, x plus 2 times x minus 3 equals x squared minus x minus 6. Fourth and final situation, first sign is negative, second sign is positive. First times first, x squared. Outer times outer, plus 3x. Inner times inner, minus 2x. Last times last, minus 6. Gather the like terms. Plus 3x minus 2x is plus 1x. But that's the same as just plus x. X minus 2 times x plus 3 equals x squared plus x minus 6. That was your introduction to the basic ideas and the step-by-step method for using FOIL with quadratic equations. And remember, quadratic just means there's something squared in the equation, such as x squared plus 1 equals 26. This part 1 video dealt with the question, how do you do it? The part 2 video deals with the questions, what does it mean? And why do you do it that way? Well, that's all for part 1. Thanks for watching. And please share these ideas with other people who can benefit from them.